All right, math scholars, let's go ahead and work through two examples of converting between slope-intercept and standard form. Starting with example 1, we're given an equation in slope-intercept form and we're asked to write it in standard form. So you'll remember from our first video, the first step is to take that entire equation and multiply it by the denominator of the slope fraction. So looking at our slope fraction, our slope is 2/3. The denominator of that fraction is 3. So I need to multiply everything in this equation by 3. So that's going to give us a new equation. 3y equals, and in this case the 3's are going to cancel and leave me 2x minus 15. Every term gets multiplied by 3. From here, we're going to solve this equation by moving things so that variables are on the same side together and the constant is by itself. So I want to get that 15 by itself, meaning I need to move that x to the other side. And to do that, we know that we either need to add or subtract it. So I look at the sign on the x, it's positive, so I'm going to subtract it from both sides of our equation. And that's going to give us a new equation. On the right, the x, 2x, and negative 2x form a zero pair. That leaves us with minus 15. On the other side, I get 3y minus 2x. And then I remember that my last step is I need to make sure that on the left, those terms are in the appropriate order. We want them in alphabetical order. That means that the negative 2x needs to be pushed to the front, and the positive 3y needs to be pushed to the back. So we're going to take these and switch them, which is going to give us minus 2x plus 3y equals minus 15. We could be finished, and that is appropriate form, looks pretty. We could do an elimination method with this. I do see something that I'm tempted to do that you might want to do if you're kind of anal retentive like me, and that's multiply both sides of this equation by -1. The reason I'm doing that is I don't really like that leading negative and the negative on the other side. If I multiply everything by -1, I get positive 2x minus 3y equals positive 15. If you graph that equation in GeoGebra, along with the line above it and the slope-intercept form we started with, you'll notice that all three of those equations produce exactly the same line. So that last step that I took is a matter of aesthetics, but if you stopped here, you'd be absolutely correct. Okay, let's try one going the other direction. Example 2 gives us the equation 5x minus 2y equals 8, and they want us to write it in slope-intercept form. In slope-intercept form, I'm basically taking those first two steps and reversing the order. I want to get y by itself, and that means the first thing I have to do is add or subtract that x term to get it on the appropriate side of the equation. Looking at that 5x, it's positive, so to get a zero pair, I'm going to subtract 5x from both sides. So that zero pair cancels, and I get minus 2y, equals 8 minus 5x. Getting closer, but we know slope-intercept form, the y should not have a coefficient. So that's my next step. I'm going to divide everything in the equation by the coefficient on the y term. And that's going to do some interesting things. So on the left side of our equation, Those negative 2's are going to cancel and leave me with y, which is what I want. For the 8 divided by negative 2, I know 8 is divisible by 2, and that's going to give me a 4 and a 1. And I know that a negative 5 divided by a negative 2, when we're doing multiplication or division, 2 negatives make a positive. So that's going to give me y equals negative 4, positive 4 over negative 1, plus 5/2 x. And you'll notice what I'm doing is with that x term, I'm grouping the numbers together as a fraction in front and then writing the x behind the fraction. Mathematically, those forms mean the same thing. This is equal to this, but this second one looks more appropriate in slope-intercept form because it makes it really easy to pick off that slope. So we should, when we go from this step to this step, make that change. We're getting a lot closer. There's one more step, and that's to focus on the right side where the x is and make sure that those two terms are in the appropriate order. And right now they're not. We need to push the x term to the front and push that constant term to the back. So doing that, we get y equals 5/2 x minus 4. And that is in slope-intercept form. I can identify my slope as 5/2. I can identify my y-intercept as negative 4. Okay, if you have any questions on how to do this, please let me know. A quick note, this skill will not be tested on your Module 5 test. I'm only introducing this because I know that some of you would prefer to use substitution instead of equal values, or substitution instead of elimination, or you want to use graphing when you're given something in standard form. And this tool will allow you to change equations into a form where you can use whatever method you want. So it opens up more tools in your toolbox, but I will not be testing you on it. There will not be a question that asks you to rewrite an equation. All the equations on your test will be given in the form that you need them for the method you're being tested on. That was a mouthful. Okay, if you have any questions, again, let me know. Drop by my classroom, send me an email. Otherwise, I will see you in week 5.